Morning, myself Prabharan J, working as a assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the introduction to DFT from Unit 1 in digital signal processing subject. Okay, let me discuss. Empathy of DFT is defect in signals is to be identified. Conversion from time domain to frequency domain takes longer time. Frequency domain information must be extracted. The discrete Fourier transform is a fundamental tool in digital signal processing with numerous applications across various field. Okay. And define of the DFT is time domain to frequency domain conversion, and process is faster. okay and frequency analysis. This is the ideate of DFT. DFT allows us to analyze signals in frequency domain by decomposing a signal into its constituent frequency. We gain insight into its spectral content, enabling us to identify important frequency components or filter out unwanted frequencies. Okay, then this is the diagram for Fourier coefficient representation. Signal processing. DFT is essential for tasks such as filtering, convolution, correlation, and spectral analysis. It provides a way to manipulate signals in the frequency domain, which can be more efficient compared to working in time domain. And data compression. The technique data compression. The technique like the fast Fourier transform, which efficiently computes the DFT, are widely used in data compression algorithm. For example, in audio and image compression, DFT based methods such as MP3, JPEG in frequency information to achieve compression while preserving perceptual quality. Okay. Discrete time sequence. We define two classes, that is DTFT is infinite duration and DFT is infinite duration. Here formula for DFT capital X of omega equal to summation n equal to infinite to minus infinite to infinite X of n, which is time domain sequence is input of the DFT, and frequency domain is output, e power minus j omega n. Okay. See, you can see this is the time and frequency domain. Time domain represented as here. This diagram illustrates the left side is time domain representation and right side is frequency domain. You can see both two representation. Time domain, frequency domain. Okay. This is the DFT formula. Capital X of k. Capital X of k is nothing but the frequency domain, and small x of small x of n is the time domain sequence. Formula is summation n equal to 0 to capital N, length of the sequence capital N minus 1, x of n, and W n of k n. Here capital N represent the length of the sequence, small n represent the number of samples, small n represent the samples, capital N represent the number of samples. Capital X of k represent the frequency domain. Small x of n represent the time domain. The DFT input of the DFT is time domain and output of the DFT is in frequency domain. This is the inverse DFT, IDFT, inverse discrete Fourier transform. IDFT input of the IDFT is frequency domain, output of IDFT is time domain. That is, capital X of k is input of the IDFT, small x of n is output of the IDFT. Output small x of n equal to 1 divided by capital N number of samples summation k equal to 0 to n minus 1 capital X of k, which is frequency domain, W n of minus nk. This is the formula for find out the IDFT from frequency, which means frequency domain convert to the time domain sequence by using IDFT. Using DFT we can convert the time domain to frequency domain. See, you can see the diagram. Small x means represent the time domain, capital X represent the frequency domain. Small x of n input of DFT and capital X of k output of the DFT, whereas same as the arrow represent the flow of the data. Capital X of k input of the IDFT, small x of n output of the IDFT. Some properties. These are the properties of DFT: linearity, time shifting property, frequency shifting, time reversal, conjugation, time convolution, frequency convolution. These are the properties of the DFT. And some of the applications, that is spectral analysis, image processing, signal processing, sound filtering, data compression. These are the applications of the DFT. And difference between DFT and IDFT. DFT is finite duration discrete frequency sequence that is obtained by sampling one period of FT. That is okay. IDFT is inverse DFT, which is used to calculate time domain representation. Time domain representation from frequency domain. DFT equation are applicable to causal finite duration sequences. IDFT is used to basically to determine sample response of a filter for which we know only transfer function, and we know the DFT formula as well as IDFT formula. This is the difference between DFT and IDFT. Okay. If you have any doubt, you can ask me through the comment. We will meet next video. Thank you.